We're not going to talk about how to become a prompt engineer in 5 minutes and earn 500K. And I'm also not going to teach you how to write better questions for ChatGPT. Instead, we're going to look at the concepts, the foundational concepts that you need whenever you want to write applications on top of LLMs. And along the way, you'll learn a ton about how they work, and that will make you, in fact, a better prompt engineer, just not in 5 minutes. Sounds like fun? Then welcome to Marco Code. All right, so here's our use case. Imagine I'm working for a startup, a not really Amazon-like website, and for whatever reason, I have a button just below gaming accessories which says book recommendation, pronto. And I just want to get, 3 or 5 books recommended. And it all happens in a programmatic context. So me as the end user, I don't want to have to chat to a system and saying, hey, I'd like some books recommended. And after some back and forth, I don't like sci-fi. I don't want the book to cost more than $10. Nope. It should all happen in a programmatic context, meaning our web application needs to prepare the prompt, send it to the LLM, and be also somewhat able to pass the response back and do something useful with it. That's the challenge we're facing in this video. Now, just to make one thing clear, because I've seen this botched a couple of times in discussions with coworkers, we've got providers like OpenAI, for example, and Anthropic, we have Google, and they have models, right? So we have the GPT models. In the case of OpenAI, we have Claude. Hopefully I said that right, I pronounced that right, for Anthropic. We've got Gemini, which was previously called Bard for Google. So just so you're aware, we have providers, we have models. And at the end of the video, I'm just going to give you a couple of guidelines on how to choose the perfect model for your use case. That being said, I'm going to be working with OpenAI and with the GPT models in this video. Everything I'm going to tell you is valid for all of these LLMs. It's just that I'm most familiar with OpenAI, its API, and so on and so forth, but we could easily do the same thing with Google's Gemini, for example. And last but not least, you can see me here. I'm being logged into the Playground, OpenAI's Playground, in a chat window where I can choose the specific model I want to execute my queries with. And this is a web interface for exactly the code that I would, then send to the API, either via Node.js, Python. These are the official libraries. There's a couple of unofficial ones also for other programming languages or the plain curl calls. And I'm just gonna go with the web interface for now. So I don't for the video, I don't hang out on the command line too much and it's a bit harder to parse. We're just gonna have a look at the visualization here. But for now, ignore everything you can see on this page here, the sidebars, the panels. I'll explain everything in due time. That brings us to basics part 2 or 3. LLMs are document completion engines, and they try to mimic documents they've seen during training. What does that mean? Well, given, for example, the question, what is the meaning of life? Now, if we send that to an LLM, there's going to be a couple of passes. The first pass is, this is my prompt, what's the meaning of life? What is going to be the next token? I'm going to simplify it now a bit and say token is a word, even though that's not completely true, which you'll see in a second. But in any case, first pass, what is the meaning of life? And the LLM said, well, the should be the most likely next word. Then another pass, what is the meaning of life? The meaning, right? Second pass. Then third pass of, fourth pass, life, and so forth. And at the end of the day, my document is being completed. Now, there's one caveat. The GPT models that we're all used to, they're trained for chat, meaning if you say, what is the meaning of life, ? You will get an answer. If you use more basic completion models, and we'll talk about those in a different video, and you say, what is the meaning of life? Why is it so short, for example? Then it could very well be that instead of an answer, you just get more questions. So why is it so short? What is going on? And then the question is, when does it stop? When do you stop, giving more questions? Just keep that in mind with the chat models. You don't have to worry about that for now. This brings us to the chat API itself. As you can see here, when I write chat messages, I have a box up here which says system, and I just put in, you're a helpful general assistant. You speak with a broken German-English accent. And then, my prompt here, what is the meaning of life, which says user. And now when I run this, I get, a message back, which, by the way, has perfect German-English with a ja. But it's, tagged with the assistant tag. Now, what is going on here with system, user, and assistant? And what you have to understand is that a very nice introduction of that came with ChatGPT was the introduction of ChatML. It's a markup language because this here looks like a chat. And I told you just a couple of seconds earlier that LLMs are document completion models. So they just complete a document you give them. Where is a document here? Because this awfully looks like a chat window. And I've just switched to my IDE. When you look at this text document I just put in here, I have a couple of lines where I put a tag in here, IM_start, IM_end, where you can put a specific role here. ChatML has system, user, and assistant as 3 roles. System is, to give you a general expectation for where the chat is going to be. So yes, you're a general helpful assistant. You speak with the broken German-English accent. That's fine. You just set, the expectation for the chat. Then you have, tagged lines, IM_start, IM_end with the user role, where you simply specify everything the user types in. So you yourself, what is the meaning of life? And then you can start with, IM_start assistant. And now the LLM knows it needs to complete the document, with an answer. That's what ChatGPT has been trained for, completing these ChatML documents. And then in the web interface, or even with the API call, you will still, when you look at this Node.js, for example, API call, you can see that you do the calls with role system, role user, role assistant. You paste in the text, so on and so forth. And you don't write these tags yourself because then there could be tag injection. We'll cover that, sometime later. Instead, the conversion to the final document with these tags will happen on the backend, and you don't have to do anything with it. On the front end, by the way, be it the normal ChatGPT web interface or this here, it will simply be passed again, and then you'll think that you have a chat going on between the user, yourself, and the assistant, which is the LLM. All right, let's get back to our book recommendation example. Remember, Amazon clone, I want to have a button, I want to push and get some book recommendations. I could just naively, use the Chat API and say, I need some book recommendations. And then I get back, ja, natürlich, yes, of course. What kind of books do you like? I don't know, I want some fiction books. And then, click run again. And then, I get some information back. That's actually not how I want it to work. Instead, I would like to say, hey, I want some book recommendations. So let's call it the introduction here. That's the book recommendations. We'll need to spell that out later. And then what you've seen probably in plenty other videos as well is I need to give the LLM some context, meaning, for example, I could track what books did the user read last. In the case of Amazon, I would actually, if the user were using Kindles, I could actually infer the read books, or what books did the user buy, or where does the user work? Does he like, technical books, non-technical books? Did the user go on vacation lately? Where did they go to? Did the user write reviews, maybe book reviews on Facebook, where the user wrote, I hate romances 5 times in a row, so let's just make sure not to put romances in here, and maybe just put these reviews as they are inside the context. Same for, I don't know, Goodreads, some reviews on Travelperk. So there's a ton of context you could actually put in here. A nice exercise for the beginning is to come up with maybe some mind maps and think of as much context that you could possibly get in a programmatic context to shoot to the LLM. You'll then have to filter it anyway, optimize it, maybe just, if it's in too much context, make summarization calls to the LLM and just put summaries there. If the user, I don't know, for example, reviewed 200 romance novels, you don't want to put, all the text here. Just a summary would work, where you said, hey, the user doesn't like romances, we're good to go. But you'll need to think about that. And then there are 2 problems. The problem is urgency or / latency, how easy or how fast it is to get this additional context. Do you have to make calls to third-party sites, to Facebook, for example? Are you even allowed to make calls to these websites? Usually not. But the further away and the longer latency, likely the more juicier the context would be for your query. Instead of just looking at your own data, at your user profile data, for example, the age and the gender, and so on and so forth of the user. But latency becomes an issue. And the whole topic of not just maybe latency, but how easy is it to prepare the context? Does it, take you then even, I don't know, a couple seconds more to prepare this document, the full prompt that we want to send to the LLM? And in the case of my book example, Maybe I push the button and it's fine if I get something back in an hour or 2 hours, or tomorrow an email, an async email. But in the case of, for example, IDEs, you want immediate responses like in milliseconds. And you don't have time to, just prepare a prompt in seconds. Let's have a look at IntelliJ IDEA real quick. So this is IntelliJ IDEA, and I say we because I work for JetBrains. We have an AI assistant, and it tries to, it lets you code, obviously. You can also make it explain code and whatnot. And for example, when I just say, explain the code to me, the real question is now, what specifically would you send to the LLM? Would you just send that code snippet to the LLM, right? Even though we reference another method, create headers here, we would actually have to, the IDE would have to be smart enough to also send in the additional methods being referenced to the LLM. And then maybe not just, the methods from this class, but also usually whenever you have files open, tabs open, they're somewhat in the same context. And it could be very useful to send, data and snippets from other referenced files and classes, or even if they're just open to the LLM. And then not just that, you could even go further and say, well, why don't we just, send in information about the project in general? So this is a Java project. It uses Spring, a couple of other things, Docker file, depending on what code I'm currently writing or what completion I just want to get and what explanation I want to get. And in the case of AI Assistant, by the way, if you want to try it out, you do have a dump chat button. You can actually see what the AI Assistant sends to the LLM. And that's for the curious people out there trying to understand how do, for example, professional IDEs work together with LLMs, what is being sent back and forth. Super interesting to get into it, but I leave it as an exercise to you. Now, we've been talking about, context, add as much context as you want. There's a limitation, which is what many people also know as the window context size, meaning that an LLM doesn't see words. That's what I, said earlier. But if you paste in stuff here, what the LLM actually will do is it will run a tokenizer and convert the text here to tokens. To make it real quick, it depends on the model you're using, but in the case of the GPT tokenizer, roughly 4 English letters, including spaces, they make up a token, right? And then you will have a token limit. The token limit is not just for the, let's say, prompt you send in, but also for the completion you get back. Because remember, there's one pass, what's the next token? Another pass, what's the next token? What's another pass, what's the next token? So with the GPT models, the paid ones for the latest models, I think it's 128,000 tokens, if I'm not mistaken. Depends on the model, depends on the pricing. And you just want to make sure that you never hit the token limit. Otherwise, you'll just get this stupid error message. Hey, I hit the token limit. You can see here in the web interface how many tokens did you use. And then you could even go on this website here where you can say, tokenizer, please, I'll just paste in my text right here. And I see for the different models, I can see how many tokens did I just use. And just in case to show you, you can paste in a fair amount of, lorem ipsum dolor, actually to hit the 128,000 tokens. But in a programmatic context, you probably don't want to use the website manually. You will want to use a tool. And for that, or a library rather, in the case of OpenAI, you have tick token, which is a library you can pull in and then quickly, for example, count the tokens for the prompt you're about to send in. And an alternative to tick token could also be the Hugging Face tokenizer library, just so you're aware of it. Talking about limitations, let's have a quick look at the most obvious problem that LLMs have, and that's access to current information. Like what, for example, is Apple's current stock price? What's the weather going to be like tomorrow? What does that book cost on Amazon? And when you run these sort of prompts, then you get back, oh, aktuelle Apple Aktienpreise, ja. Sorry, I can't help you. The interesting thing is that the Chat API introduced the ability to have functions. Let me quickly show you what these functions are. When you click Add Function, here in the dashboard, in the playground, there are some example functions. And they're really just high-level descriptions of possible functions that your application possesses. So what I'm saying here is that my application has a method which is called getStockPrice, which gets the current stock price. It's just a description. It's just text here. This is all just text. Don't think that this is being compiled or anything. It's essentially just text, which is going to be tokenized again. It's taken away from it. It uses your token limit and so on and so forth. But nevertheless, the getStockPrice function has one parameter. It's of type string. It's the stock symbol, right? It's going to be required. Now let's save the function here and let's execute the request again. Let's see what happens. And now the assistant gives me a different answer, because now the assistant or the LLM knows, well, it doesn't know the answer, but it knows the user has a function they can call themselves to get the stock price. Hence, the assistant returns me that function and basically filled out nicely for me to call. Remember we said the getStockPrice, it needs a symbol, it's an object, it's required. So the LLM just, formed together a perfect request, so to speak, that I now have to evaluate. So I would need to take the text here. And by the way, when you look at the code here, just so you're aware, if I did that now on the command line, really what I would get back, I would get this object here back, where say result is going to the assistant, said there's no text in the response, but there's a tool call, type function, just call getStockPrice with these arguments. I would have to, in the case of Node.js, I wouldn't eval these arguments. And then, I don't know, get $10,000 back in the case of Apple, or however much they are. And then my application could return the stock price to the user directly, or I don't know whatever else is going on in the background. And that brings us to, let's say, the concept of a loop. Because when we're chatting with ChatGPT, there's one question and then you get an answer back. In the case of these simple wrapper plugins, for example, summarizes whatever, you're on a website and you just mark some text, summarize the text for me. There's always simple request response. But in fact, you should view the whole life cycle as kind of a repetitive, a stateful loop, so to speak, where it could be that you have to send in, 1, 2, 3, 4, 5 requests to the LLM, do something with the response, send it back again before, giving the results, the intermediary results, back to the user, right? Stateful also means that you need to keep track of the conversation, which, by the way, brings us to another misconception that people sometimes have, and that ChatGPT is not stateful. Again, it's just, a document completion engine, meaning that if you do these repetitive loops back and forth, you always need to send with your code, you need to send everything the user has written so far and the LLM has given you. You need to send it back in the API calls. That's when you look at the code now for this little chat window here in the background, you can see there's my system call. There is what the user wrote. This is the first response I got from the assistant. Another user question, then the assistant again. I need to send all these back again to the API because remember, at the end of the day, all of that is being converted to one document, just one tiny document with these tags, with these ChatML tags. And the only thing that happens is that the document will be completed even more. And that's why your application has to keep track of the state. Now I need to make a transition to the Valley of May. Let's get back to our book example. For a second, ignore the functions, ignore the limitations. We're back. I want some book recommendations. I don't like romances. So a bit of context. So my context now is 3 sentences. Better than nothing. It's not too much, but that's it. Imagine, for whatever reason, I was pasting in, the Goodread reviews and all the other stuff. So I have a ton of context here. In terms of the LLM, this is kind of, here's the intro, the first line, the first couple of lines. I want some book recommendations. Then you have all these context lines. And at the end of the day, you need something which is called refocus and transition, where you say, well, now I told you, 20 pages about the context. I'll just quickly go and tell you, I wanted some book suggestions. And then now you can give me an answer. So I think this is enough information about myself. You can now give me a book recommendation. What should I read next? So you have to, bring the LLM back to focus on the question at hand. Now, something which I didn't really know about is, and I'll paste a link below for the references, is that when I mentioned Valley of May, hopefully I'm pronouncing that right, May, that LLMs have, as humans, the tendency to basically put more emphasis on what's written, earlier or at the end of the prompt, and tend to kind of ignore what's written, in the middle. That's the Valley of Meh. if I can make a German sheep like that. Now, and that brings us to the topic of, when you have so much context, you actually need to, as I mentioned before, filter it out, optimize it, prioritize it, drop out some stuff, put, stuff that is not so important in the middle of it, in the middle of your prompt. And all of that alone is going to take you more than 5 minutes to learn, more than I can show you in this video. You'll have to read a book about it, about this context engineering, so to speak. And again, I'll link the recommended chapters about it down in the description. But just so you're aware that you want to essentially sandwich whatever prompt you're sending. You have the intro, book recommendations, then the context, whatever you have, and then the sandwich at the end. Again, just refocus again. Hey, we're still talking about book recommendations, and that's what you send to the LLM. And one last thing, while we're at it, what people much smarter than me found out is that you tend to get slightly better recommendations if instead of, I want some book recommendations, I don't like romances, you introduce a third person, right, that you actually want to have, in this case, recommendations for. So in this case, I might change the prompt to, I'm wondering which books to recommend to Marco, to myself. And then I wouldn't write, I don't like romances, but I would write Marco doesn't like romances, for example, and that sort of stuff. The interesting thing is, depending on how much context you give, if, for example, you're a German bookshop, and that's the context you're setting here, then the recommendations you'll get also depend on the type of name you put here, right? If it's like a German, foreign sounding name, or if it's like kind of a native German sounding name, or whatever that means, you'll actually get different recommendations. You might get more touristy recommendations. That's very interesting to play with. And again, it's something I'll link you down below where you can read more about that. But in short, introduce a third person for potentially better results. We've been babbling along about the what to send. So we talked about, the intro, the context, the refocus, transition, blah, 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 blah. The question is, how do we send it also? Are we just going to, send text, meaning that I'll have string templates littered across my project, and then I'm just going to replace, I have a string template, and then, I have a name placeholder here, and then, book topic like that with a for loop, something like that. How would I actually construct the prompt programmatically? And what's important to understand is there's certain types of conversations you can have with an LLM, and it depends a bit on the project you're writing. So all of these, chat/assistance-like conversations where you put in, plain text and you get plain text back, they might make sense. As I said, for the simple wrapper. At the beginning, where you say summarize this page of text, you can just blast a query to the LLM, maybe do a quick replacement somewhere, and then send plain text back again. But in our case, it gets a bit tricky. I mean, with the context, and then maybe having more and more string templates. So we might think of for having some sort of a structured document, meaning I want to potentially send XML, YAML, JSON, and receive XML, YAML, JSON. And by the way, you could also send Jupyter notebooks, which you can export to Markdown, JSON, whatever, and get the LLM to complete these Jupyter notebooks for you, because that's a trick I'm going to show you. You could obviously just say, I like books about cooking, and give me recommendations, and please return them in XML format, and give some examples of these XML formats, what they should read next. But we can also make it a bit smarter, and maybe just send one big XML document to the LLM and let the LLM complete that. Let's see what that looks like. Now, I crafted a tiny broken XML, which, by the way, includes my initial prompt, my question, the context, and potentially, hopefully, the answer soon to my question. And LLMs are pretty great at completing XML, JSON documents, and so on and so forth, because, they've seen plenty of these documents during training. And what I did is I came up with, I just called the root tag question. I give it a body. What books should Marco read next? So that is my query. Then I want to give a bit of background. Again, it's just a random XML tag. So background is, there was a book review. Marco hates books about cooking. Marco loves books about fishing. Maybe the spending limit is $20, whatever. That would be my context that you saw me type in earlier as plain text, natural language. Then I specify a suggestion form. That's the answer I want to get. The answer means I want to get some book suggestions back in XML tags, and they should have, a name field. They should have a description field. And then I simply open up a suggestions tag with an open book tag, and that's it. And I'm going to send that to the LLM now. Here we go. I just pasted it into one line. Let's click run and let's see what happens. What ChatGPT does, or what GPT-4o does. And as you can see, interestingly enough, you simply get suggestions back as XML. So suggestions, there's one, there's another one, two suggestions in here with name, The Old Man and the Sea by Ernest Hemingway, a river runs through it, including a description. And that's super cool because it's actually very easy for me to kind of construct this sort of XML document when sending the prompt. And it's also relatively easy, as opposed to natural language processing, to parse the incoming suggestions that come back from the LLM. When you look at the code, viewed as the code, you can see you simply get that back, as text here from the assistant, role assistant, as text, XML, and then you just need to be sure to parse it. There is one caveat though. The caveat being that, as you can see already, that, suggestions book here, if you just combined, my query with the suggestions coming back here, you wouldn't get a completely valid XML document. And it brings us to the bigger topic of error handling in a programmatic context. What happens if you, send something in and you get something back in an unwanted format? If, for example, I don't know, the tags here suddenly have a different name, you need to make sure that your program is error resilient. Actually, it's a topic I'd like you to think about and write me a comment down below on what potential errors you could see here in a programmatic context and how you would handle those. And then I will actually make a different video about these once we work through a full tutorial on how to write our first real application. In any case, we've been babbling about a ton of, foundational concepts so far. Let's circle back to the beginning on the topic of how to choose the perfect model for your use case. Whenever you want to choose a model, there's a couple of considerations you have to make. How smart is the model? How fast or how is the speed of the model? How much does the model cost? How convenient is it to work with the model, with the API? Do you have stuff like the functions you saw earlier? Do you have some legal considerations? All of that. But just looking at the cost, for example, the pricing of OpenAI, when you look at the GPT-4o pricing, you see it costs roughly $5 for 1 million input tokens, so just the tokens you send in, and then $15 for 1 million output tokens, so the responses, the completions you get. When you look at the GPT 3.5 Turbo model, you can see it comes in at 50 cents or $1.50 for a million input tokens and a million output tokens, which is an order of a magnitude less. And it really depends. I mean, if you're working on a solo startup, you have no users and you always want the perfect response, but you only send one prompt to your LLM a day, then go with the most expensive model. If you want to have, fast responses to more spammier, requests, just go with the cheaper model. But at the moment, you can't eat your cake and have it too. You can't have the fastest model ever, the cheapest model ever, the smartest model ever, all combined doesn't work. And last but not least, you wouldn't want to make your own model, but you could fine-tune a model. But that by itself would make another, I don't know how many videos, and would need someone smarter than me to walk you through it. To sum things up, we've learned a lot of concepts, 848,000 in this video, and I left out a couple thousand more. But we haven't built a real world project yet. If you want to see me apply all these concepts you just learned about in a real, live video walkthrough for a Chrome plugin, for example, or something else, then just leave me a comment down below and I'll write something for you. That's all I got for today. Hope you learned something new. Sayonara.